Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 20 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this series of most excellent lessons. And in this class, we are using the Sunfounder Raspberry Pi Raphael kit. Most of you guys probably already have your hardware. If you don't, look down in the description. There is a link over to Amazon where you can pick up this kit. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how you can control the position of the servo from the potentiometer using the Raspberry Pi. And this is actually the homework solution to the homework that I gave you in lesson number 19. So let's be honest. How many of you were successful in doing the homework? If you were successful, leave a comment down below. I am legend. Or if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. And we have added an additional category of people, and those are, I never even entered the arena. Okay, you didn't even try. Well, really, it's okay to try and succeed, and it's okay to try and fail. But man, at least go in there and give it a try to get to the solution before you watch me do it. Because when you watch me do it, it looks easy, and you really don't understand. You really don't fully comprehend whether you understand it or not until you try to do it on your own. But enough of this introductory chit chat. Let's jump in and let's get going with getting our circuit built and getting our code done. First of all, what I will say is that we are starting out with the circuit that we left off with in lesson number 15 in this playlist. And what lesson number 15 was analog input on the Raspberry Pi using the ADC0834. So we showed you how to hook up the ADC0834 to the Raspberry Pi breakout board, which was connected to the Raspberry Pi. And then we had this, the ADC0834 is basically a way to do analog input on the Raspberry Pi. And then we demonstrated it by having a potentiometer hooked up to it. And so this shows you how to hook it up. You can also go back and get the schematic at lesson number 15, or I will flash the schematic up here for you, and you can kind of grab this and freeze this, and then you can go out and you can hook up your ADC0834 to your potentiometer according to the schematic. Guys, I'm going to be honest with you. For a long time, I would just leave this circuit hooked up on your breadboard. I would leave this circuit hooked up on your breadboard, because anytime we need analog input, we're going to need this ADC0834 hooked up. And I would just hook it up, leave it hooked up, and then anytime you need an analog input, you can just connect to this chip. But it's something like I get tired of taking it apart and putting it back together. And there's enough room on the breadboard to still add other things that we might want to add. So you need to go ahead and get that hooked up. And then in your Sunfounder kit, you need to get out your servo. In last week's lesson number 19, I showed you how to connect and use the servo. And so basically, I'm going to take this circuit setup from lesson number 15, and I'm going to hook the servo up like I showed you in lesson number 19, and then we're going to see if we can code this thing up. All right, now I explained in lesson number 19, you're going to have to connect some wires here in order to get this servo into your circuit. And we remember red is for the supply voltage. Brown is ground, brown ground, and orange is control. I also explained ad nauseum in lesson number 19, you can power one of these small little servos that comes in the kit off the Raspberry Pi, but if you get a bigger servo, you can fry your Pi if you try to power it from the 3.3 volts on the Raspberry Pi board. And so if you get a bigger servo, you need to power it, connect the red wire to an external 3.3 volt supply voltage, and then you can control it orange wire from the Raspberry Pi. And you've just got to make sure to have a common ground so that the ground of the ADC0834, the ground of the potentiometer, and the ground of the Raspberry Pi and the ground of your external voltage supply are all tied together. The entire circuit has to have a common ground. And if you do that, then you can power red wire your servo from an external 3.3 volt source, if that makes sense. But because we are using this tiny servo, we're going to power it from the Raspberry Pi. I also explained last week about how I like to keep the colors consistent. So my red power line is going to go to a red wire. That's the center one. And then orange is going to go to an orange wire. All right. And then brown is going to go to a black wire because brown is ground. And so what I'm going to do is I'm going to take the black wire and I'm going to come over here and I'm going to connect it to the ground pin right here. Okay, so the nice thing is these are marked and you should be able to read that that is ground. And then I'm going to connect the red wire to 3.3 volts, which on the bottom is the leftmost connection. Like that. And now I need to find a convenient pin for control. And if I look on here, it looks like GPIO 4 right here would be a convenient pin. I think last time we did 18 over here, but you can see 18 is being used by the ADC0834, so I'm going to use the pin 4, and now my servo is all here together, kind of nice and neat and all together. So I believe at this point I have the circuit hooked up, and with the circuit hooked up, I am ready to jump in and start coding. So let's see if I can go over to a code view here. This looks pretty good. I think you'll be able to see what I'm doing. Maybe I'll put the servo over here where you can see the servo, and then we can see the code view. So with this now, what I need you to do is come over here and fire up your Thony, your Python IDE or integrated development environment. So I come down to Thony, I fire it up. Hopefully we get something. Boom, there we do. We have it. I think I will go ahead and save the program. So I'll say save as, and what do we want to call this? I think I will call it pot servo, like that. I've got a pot and I got a servo. I will save it like that, and boom, fresh new Python program, just waiting for you to write it. So let's go ahead and start getting the libraries that we know we're going to need. Well, we're working with the GPIO pin, so we need to import rp little I dot GPIO as GPIO. You can import it as whatever you want. GPIO is descriptive, so I'll use that. Also, we're going to need to use the ADC0834 library. Heads up, I showed you how to install the ADC0834 library in lesson number 15. If you're one of these drive-by shooters that are not going through these lessons methodically and in order, you need to go back to lesson number 15 and you need to see how to install the ADC0834 library. But since we did lesson number 15, I can just say import and import ADC08, and that's 0834, import ADC0834. Now we're probably going to want to put a delay in here, so I'm going to say from time import sleep. Why did I not just say import time? If I would have just imported time, anytime I wanted to put a delay, I would have to put the command time.sleep some amount. If I import from time import sleep. Then in order to sleep, all I got to do is just say sleep and then some amount of time. Hope that makes sense. Just makes things a little bit neater, cleaner later on. Now we got to tell it what board scheme we're using. And if you remember over here, this breakout board is labeled not with the physical pin numbers, but the BCM pin numbers. And so this control line is GPIO4. Well, that's the BCM numbering system. The BCM numbering system. And so in order to do that, then that is not where I was. This is where I was. Okay. In order to do that, then what I need to do is a GPIO.set mode. And the mode I'm going to set is GPIO.BCM for the Broadcom numbering system on the pin. So that should be good. Now I will need to send will I need to send a PWM signal? Yes, I will need to send a PWM signal to the servo. So I got to set up my PWM business. So I've got to say my PWM pin is equal to 4 because that was GPIO pin 4 over down on my circuit. So I'll set that up to pin 4. Now I need to set up that pin. So I'm going to say GPIO.setup. And then what I'm going to set up my PWM pin. And what am I going to set it up to be? A GPIO.out like that. And after a while, you get in the habit of the uppercase, lowercase, but man, it's kind of crazy the way Raspberry Pi does this as far as what's an uppercase and what's a lowercase and what's a camel case and all those different things. So be very mindful of case because it has to be perfect. This is case sensitive. Now I've got to set up my PWM object, and I do that with the command GPIO.PWM all uppercase, and then where am I going to set it up on PWM pin, so it'll know now that my PWM object is connected to pin 4 because it knows what PWM pin is. And now I have to set the frequency. Now remember, to do servo control, it needs a period of 20 milliseconds, okay? But the GPIO pin doesn't want to know that. It wants to know a frequency. Frequency is 1 over. Frequency is 1 over the period. And so 1 divided by 0.02 is 50, so the frequency is 50 here. All right. Now what I need to do is I need to go ahead and start my PWM. So I'm going to say PWM.start, and I'll go ahead and start it at 0 duty cycle. And then I need to go ahead and fire up my ADC0834 chip. So I'll say ADC0834 set up. That should get it going. I don't have to send it any parameters. And now what I need to do is set up my try and accept, because I always want to leave the program gracefully and clean up. So I'll have a try, which will be where all the actual action happens. And then I will have an accept, and my accept is this is another one that's always confusing. Key, uppercase, keyboard, all lowercase, and then interrupt like that. Get your case right. It really does matter. And that means when you're in the try and you're looping and you see a Control C, then you hop down here to your keyboard, interrupt, your accept, and then what you're going to do is a GPIO.cleanup. Like that. And then I'm going to print something just so that I know that it reached here. And what am I going to print? GPIO good to go, like that, in that, like that. All right. So now if I hit a Control C, it should come down and clean up my GPIO pins, which is in fact kind of important. All right. Now what I want to do is I'm going to read from the potentiometer, and then I'm going to write to the servo. And so when the potentiometer is always all the way to the left, I want the servo to be all the way to the left. And then as I turn the potentiometer, I want the servo to move smoothly in in response to the position of the potentiometer, and I want full range of motion of the potentiometer to lead to full range of motion of the servo. Does that make sense? Okay, now how do we do that? We just start trial and erroring and guess and checking, right? No, wrong. Who's your friend? Math is your friend. And so we are going to come over here. We are going to come over here, hopefully, to our sketch pad. Okay, we're going to hopefully come over here to our sketch pad. And you're going to have to give me just a little second here to get this set up. I'm kind of having to switch from one configuration to another. And so now I hope I have the sketch pad that I can bring up. Oh, okay, yeah, you've got the sketch pad. So how do we do the math? Well, we've got to think about what we're reading, and then we got to think about what we are writing. Okay, and so let's start with what we are reading. Let me come down here. Okay, let me come down here and get a nice blue. So what are we reading? We are reading from the potentiometer through the ADC0834, and we are reading a number from 0 to 255. Okay, a number from 0 to 255. This is what is coming in. And now what is going out? Well, when I am reading 0, I want the servo to be all the way to the right, and all the way to the right would be what signal would put it there. From last week, it was a duty cycle of 2. So if I put on the PWM to the servo a duty cycle of 2, my servo will read hard right, which is 0 degrees. Okay, but now if I turn the potentiometer all the way to the right, then I'm going to be reading what? I'm going to be reading 255, and then in that case, I want the servo to be all the way over at 180 degrees, and in order to get the servo to 180 degrees, I need to send a duty cycle of what? 12. Now, where did I get these numbers? Where did I get these numbers 2 and 12? That was last week's lesson where I showed you how to do the servo, that a pulse width modulation duty cycle between 2 and 12 will take the survey, 2% and 12% will take the servo from 0 degrees over to 180 degrees. Well, now what we have to do is a little bit of what? We got to do a little bit of math. Well, what do I have? I have 2 points, and the first point is if I read a 0, I want to apply a 2. If I'm reading 0 from the potentiometer, I want to send 2 to the servo. If I am reading 255 from the potentiometer, then what do I want to put on the servo? I want to put 12. So I have 2 points. From 2 points, I can make a line, but I have to start by calculating the slope of the line. The slope of the line, m, is equal to what? y2 minus y1 over, I like to use parentheses, over x2 minus x1. Hopefully this makes sense from your old friend Mr. Algebra 1. And so now let's put the numbers in. M is equal to, what's y2? y2 is 12. So it's going to be 12 minus y1, which is 2, over x2, which is 255, minus x1, which is 0. And so my slope comes up to a nice, neat 10 divided by 255. Now, I don't have to reduce that down to a decimal. I can just put the equation in like that. But we're going to come up now, what is the equation of a line? Well, it's y minus y1, the y value of the first point, minus m, the slope, onto x minus x1. Well, I've got a point, and I'm going to use this one, because the 0 will make the math a little easier. So I'm going to have y minus y1, which is 2, is equal to m, which we just calculated down here, which is 10 divided by 255 onto x minus x1. What was x1? x1 was 0 over here. Okay, so now I have y minus 2 is equal to 10 divided by 255 times x, and then we're going to finish it up by saying y will add 2 to both sides. We will add 2 to both sides, and we're going to get y is equal to 10 divided by 255 times x plus 2. All right. Now, what is y for us? Well, y is going to be the PWM. Y is going to be the analog val. That's what, or I'm sorry. Let me let me be careful the way I put it. Y is the PWM val. That's what we calculated, the PWM val. And y depends on x, and x is what? X is the analog val that I read from the potentiometer. So I can rewrite this as PWM val is equal to 10 divided by 255 times analog val, close your parentheses, and I'm going to be a good boy and I'm going to get out of your way, analog val, and then the plus 2. All right. And so now this is the equation where we are going to read an analog val, and then we're going to calculate a PWM val, and then we'll send that PWM val to the servo. Guys, does this make sense? Math is your friend. It's this equation that's going to allow us to make this thing work really well. But I think now we are ready to move back to our code view. So I will come over here and I will do a little bit of Windows management here. And then I think I need to come back over here. Oh yeah, I was in the right spot. So this is the code. We already started writing the code, and we got down to the try and accept, and we realized in order to move forward, yeah, I can read an analog val from the potentiometer, but now I got to calculate my PWM value. So, or what did I call it? My PWM percent. So what do I need to do? The first thing I need to do is I need to read from the ADC0834. So I'm going to read the analog val, and that is going to be equal to my ADC0834, and then I need to do a .get result with an uppercase R. And then what am I getting a result from? Well, if you remember, we hooked the potentiometer, the center leg of the potentiometer, we hooked to channel 0. Actually, if I look at it closely, I don't want to rewire this, but I've got it connected to channel 1 because channel 0 I have empty, or do I? No. This, in fact, is channel 0 when I look closely. It is channel 0. Its pin 3 is channel 0. And so I'll come back over here to the code view, seeing that I am on channel 0. I will read from channel 0, which is pin 3 on the ADC0834 chip. Now that I have analog val, I need to calculate what? PWM percent, and we just did some most beautiful math that told us that you take 10 divided by 255, which is the slope, and then you multiply that by what? Analog val that we just read, close your parentheses, and then we add 2 to it because that was the equation of the line. Okay, now what do? We come down here. I think I'm going to go ahead just to help me debug. I am going to print I'm going to print the PWM percent just to make sure that I'm getting what I expect. As I move that potentiometer, I should be seeing a calculated PWM percent to go from 2 up to 12. And maybe not exactly, because maybe this potentiometer doesn't go exactly all the way precisely to the endpoints, but it should be something very close to 2 up to something very close to 12. Now, once I've printed that, I need to go ahead and apply that to the servo. I need to write that value to the servo. So my servo object was PWM. Okay, and then it already knows that the PWM pin is pin 4 because that was up earlier in the code, but I've just got to do PWM dot change duty cycle like that. And what am I going to change it to? That PWM percent per percent that I just calculated like that. Also, you don't want to just sit and hammer the servo too quickly. You can go so fast on something like the Raspberry Pi that you can hammer that servo so quickly that it gets very confused and has trouble keeping up. So I really like to always, as a matter of good practice, put a little bit of a delay, and I'm going to say sleep 1/10 of a second, and that should be nice. Okay, and now let's see what else we've got. Then we come down to the accept. And then I will come over here like this. Okay, and no telling where that is, but let me make sure. Also, guys, with these wires, you've really got to make sure, if you want good readings and good outputs, you've got to make sure that you've got good connections. And so I think that I can, let me go ahead and run this, and then we'll see if we're getting errors. And then if we're not getting errors, we'll go back over to the other view. So I will need everyone to hold their breath. Oh, denied. Oh, the ADC0835 denied. That is line 9. Were you guys yelling at me? ADC0834. I hit a wrong key. Hold your breath. Okay, and this is, oh, it's giving me a warning. Why is it giving me a warning? Because when the program crashed, I didn't get down to the accept, the keyboard interrupt, and I didn't release those pins for good measure. Let's see. You know what else I forgot? The way I did this, it's going to run one time and stop, which is exactly what it did. In order for it to keep looping, I need to put a loop in here. So I'll say while true, like that one is true, true, true is always true. And then in there, I need to tab these over so they're all inside of that while clause. Okay, so now let's run this thing and let's see what happens. Hold your breath. Okay, so I'm getting an 11.49. All right, and now let me see if I can make sure that I got these things plugged in good. Okay, so you can see I had a little bit of not the perfect connection. And so now let's look and see where you can see that I am... Okay, I need to turn it the other way. Okay, so you can see I've got the wires coming out the right. Or do I need to do that? Now I'm confused. Hold on. Come here. Okay, it's spinning the wrong way, so I think I need to try. I'm going to have to get my horn position synchronized with my potentiometer. Okay. So now this is synchronized, right? Because you see, when you put that horn on there, you really don't know what angle it was the last time you ran it. And so you've got to adjust it so that you get your horn position in sync with your software and your hardware. And so now if I come over here to the overall view, what you can see here is that my potentiometer is all the way hard left. When my potentiometer is all the way hard left, my servo is hard left. Okay, so they're in sync, that the position of the potentiometer matches the position of the servo. Now that was a bunch of shucking and jiving to get it to line up right, but now if the math works, as I twist the potentiometer to the right, the servo should smoothly move from its present position to the 180 degree position. And so we're starting to move it. And as I am moving it, you can see that the servo is responding quite nicely. And then I'm going to come on all the way over. And then as I get over, boom, I am over to that 180-degree position. And now if I go back, you can see that I come to 0, and then I come all the way to 180. Now what you can see is that with this setup, I am not quite getting, that's pretty close to 180. That's pretty close to 180. But I am getting a little bit of noise in this. And probably what I need to do is just go in and really, really firm up these connections, because you don't want any noise in these connections at all. But all the way to the right, the servo is all the way to the right. If I put this sort of like up and down, you see how this is up and down, this is up and down, and then I bring it back to the full left position, and the servo is full left. Is this neat or what, guys? Is this neat or what? This is why I love this. I mean, think about what we're doing. We're using the Raspberry Pi. We're interacting with the external world through the GPIO pins. We are reading from one device, the potentiometer. We are doing a calculation, and then through an ADC0834, we are reading a calculated value, and then we are sending that value using PWM to a servo to get it to move where we want it to move. Guys, this is really neat. This is really, really neat, because even though this seems kind of simple, there's a lot of different stuff here. You're doing a lot of stuff. You're doing math, you're doing circuits, you're doing programming, you're doing building, you're doing thinking. And so you're doing a fairly broad range of things with this project, and a lot more than if you just sat down at like Code Academy or Code Camp or one of those things and just wrote a Python program using their little Python window. Here you are really bringing it all together to do something that I think is pretty darn neat. And so what we have done so far, let's review what we have done in this class. We can read digital signals from the GPIO. We can read analog signals from the GPIO pins. We can write digital signals to the GPIO pins, and we can simulate writing analog to the GPIO pins using pulse width modulation. And so that is a pretty slick tool set. And now we're starting to connect the two. We are analog reading from the potentiometer and then PWMing out to the servo, and then we're getting some pretty neat things happening. Guys, I hope you are enjoying taking these lessons as much as I am making them. I am having a whole lot of fun. What we're going to be doing is, in these future lessons, we're going to be going as quickly as we can through as many of these different components in here as what seem like fun and interesting. And then after we get through the main components in here, then we're going to connect the camera. And that's when the magic's going to happen. That's when the real fun is going to start. But I don't want to ignore all the different slick components in here. So we'll be doing more of these component examples. I'll try to, as much as possible, give you homeworks. You guys, if you didn't do this homework, what you need to do is you need to now, not watching me, you need to do it on your own without watching me. And then next week, we will be jumping into a new component. Okay, guys, if you enjoyed this video, give us a thumbs up. Man, I've kind of been losing some momentum on YouTube recently because the YouTube algorithms have changed in order to try to promote content providers who have certain worldviews and have certain politics and have certain, members of certain groups and lifestyles and things like that. And what's happening is one of those groups that they're trying to promote is not grumpy old white guy. Okay, so those of us who are grumpy old guys, we're kind of on our own, and I'm not the only guy that's getting hit with this. But if you want to help me, leave a thumbs up, leave a comment, subscribe to the channel, ring the bell to get notifications, and then share this with your friends, and then more people will see this video. And that's important because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.